Hello, welcome to the second lecture of laws of illumination and types of lamps. So let us take up one problem. The total flux emitted by a 100 watt lamp is 1400 lumen placed in a frosted globe of 4 mm diameter, and it gives a uniform brightness of 25 lumen per meter square in all directions. Calculate the candle power of the globe and percentage of light absorbed by the globe. So a 100 watt lamp is placed inside a globe, inside a spherical globe, and the radius, diameter of this globe is 4 mm. So frosted globe means some frost is present on the surface of the globe, and it is emitting light in all directions with a uniform brightness of 25 lumen per meter square. Okay. Now, what is the total power, light absorbed by this globe? That is the question. First, flux emitted by this globe is given by luminous flux emitted by globe. So this is given by the formula brightness into globe area, the total surface area of the globe. Okay, so what is the brightness is telling? It is giving 25 lumen per meter square multiplied by the total surface area of the globe is 4 pi into r square, where r is 2 meter 2 square. So if you calculate this, you're going to get 100 into 4 pi, so many lumen is the total luminous flux emitted by this globe. So this amounts to be how much? If you calculate it, 1256.63 lumen, LM. Understand? Now, what is the total lumens emitted by the lamp? It is 1400. So, but the globe is emitting only 1256.63 lumen. So the flux absorbed by the globe, or lumens or luminous flux absorbed by the globe, is how much? 1400 minus 1256.63. This value is 143.36 lumen is absorbed by the globe. So percentage of light or lumens absorbed by globe is given by given by 143.36 divided by 1400 into 100. So this amounts to how much? 10.24% is the percentage of luminous flux or lumens or light that is absorbed by this frosted globe. Understand? Now the next question is, a surface is inclined at an angle 40 to the rays and is kept 6 meters away from the 150 candle power lamp. Find the average intensity of illumination on the surface. So here you can see in the question, this is a source, and what is its candle power? It is luminance intensity is 150 candle hour, 150 candle power. Okay, now what is the angle made by the surface? The surface is making an angle of how much? It is inclined 40 degrees with respect to the incident light ray. This is the incident light ray. It is making an angle of 40. Then what is the angle between the normal to the normal of the surface with this incident light? It will become how much? Your theta will become 50 degrees. So we always have to calculate the angle between the normal of the surface and the incident light ray. Here that angle is 50 degrees. That angle is 50 degrees. This is the normal. And this is the incident light direction. So the angle between these two is how much? The angle between these two is 50 degrees. So your theta value is 50 degrees. Understand? Now, the illumination at the surface, illumination at surface is given by luminous intensity of the lamp divided by d square into cos theta. D square into cos theta, where d is directly given. D is the distance from the lamp to the surface is given as 4 meter. So luminous intensity is 150 candela or candle power into 4 square into cos of 50 degrees. Understand? This is the illumination at the surface, whose value is how much? If you calculate this, you're going to get 6.026 lux. That is the illumination of the surface. Illumination at the surface. Understand? So next question we'll see the illumination at a point on the working plane directly below the lamp is 60 lumen per meter square. 60 lumen per meter square. The lamp gives 130 candle power uniformly below the horizontal plane. Determine the height at which the lamp is suspended. The illumination at a point on a working plane 2.8 meters away from the vertical axis of the lamp. Vertical axis of the lamp. So here this distance is 2.8 meters. This distance is 2.8 meter, and we have to compute the height, and the angle theta is not mentioned. Okay, so first let us call this point as A, as mentioned below. Illumination at a point A, illumination at a point which is directly below the lamp source is given by what? Luminous intensity I by h square. Here cos theta value is 0 because, so directly we can write this one, which implies your h will become how much? H will become I divided by EA. H square will become I divided by EA, and h will become I divided by EA under root. Let us. Okay. So what is the luminous intensity at a point directly below the lamp is how much? 60 lumen per meter square, and luminous intensity of the candle is 130. So 130 divided by 60 under root. So if you calculate this value, your height is 1.47 meter. 1.47 meter is the height of the source above the from point A. So this value is 1.47 meter. Understand? Now we have to calculate the illumination at point B. So illumination at point B is given by I by d square into cos theta, where d value is this one. So how to compute the d value? So d value is this one, whose value is 0.8 square plus 1.47 square. If you calculate, you're going to get the d value. So if you, and theta value is, cos theta value will become 1.47 divided by 2.8 square plus 1.47 square. So this is your cos theta value. So by substituting these values, you're going to get the answer as 11.54 lux is the illumination at point B. Okay. So now let us see the last question. So two sources S1 and S2 are there. the luminous intensity of the source S1 is 200 cp and of that of S2 is 250 cp, and the distances are given in the images. So at point P, exactly at the middle of the post, let us call the middle of this path, here it is point P. So at this point we need to calculate the illumination because of these two sources. Now first, if we calculate D1, what is the value of D1? Your D1 is hypotenuse in the first right angle triangle. It is given by 8 square plus 20 square. 8 square plus 20 square. And what is D2? D2 is 10 square plus 20 square. 10 square plus 20 square. So the D1 value turns out to be 21.54 meter and D2 value turns out to be 22.36 meter. Understand? Now what is cos theta 1? Cos theta 1 is given by 8 divided by hypotenuse 21.54. So this value turns out to be 0.37, and cos theta 2 value is 10 divided by 22.36. So from this we are going to get this value as 0.447. Okay. Now illumination at point P due to source S1 is given by, what is the formula? Luminous intensity of the source 1, that is, let us say I1 divided by the distance is D1 square into cos theta 1. I1 divided by D1 square into cos theta 1. So the luminous intensity of first source is 200 divided by the distance value we have computed is 21.54 whole square into cos theta 1 value is 0.37. So this value will give you how much? 0.159 lux. So this is the illumination at point P because of source 1 alone. Now similarly, illumination at point P due to source 2. It is given by luminous intensity of source 2 into D2 square into cos theta 2. So if you substitute, what is the luminous intensity of second source? 250 candle power, and D2 value we have computed, cos theta 2 value also we have computed. So this value is 250 divided by 22.36 whole square into cos theta is 0.447. So this value turns out to be 0.2235 lux. So this is the luminous intensity because of source 2 alone at point P. So total illumination at point P due to S1 and S2 both sources together, this value will become illumination because of first source, that is 0.159 lux plus 0.2235 lux because of second source. This value is 0.3825 lux. So this is the illumination at this point because of these two sources acting together. Okay, so these are a few numerical switch models that may help you in your exam. Now let us discuss the next topic, type of lamps. So the lighting industry makes millions and millions of lamps every year, artificial lighting sources called lamps. So they are used for providing illumination, and basically the lamps can be broadly classified into three types. They are incandescent lamps, discharge lamps, and solid state lamps. So incandescent lamps produce light by heating a filament until it glows. So in incandescent lamps, we heat a metal filament, and after attaining a particular heat, it becomes incandescent. That means it starts emitting the light. So discharge lamps produce light by ionizing the gas through electrical discharge inside the lamp. So there will be a gas that will be present between the two electrodes, and the discharge should occur between this gas, so that this gas should become ionized because of the supply electric voltage. Then only the lamp will glow. In solid state lamps are nothing but the LED lamps. A phenomenon called electroluminescence is used to convert the electrical energy into direct light. So in LEDs, because of electroluminescence, the electrical energy is directly converted into light. The illuminance or the illumination on the earth surface produced by daylight can cover a large range. That means because of the intensity of the sun, so on a summer sunny day, the illumination on the surface of the earth because of the sun, it is 1,50,000 lux, and on a very, very gloomy, heavily overcast day in winter, it can reduce up to 1,000 lux. So the illumination on the surface of the earth because of the sun, it varies in a wide range, that is 1,50,000 lux on a bright sunny summer day to 1,000 lux on a heavily overcasted winter day. Okay. Next, let us understand few terms. First term is color rendering index, CRI. Color rendering index is a measurement of how well a lamp illuminates the color, or how sharp the colors will appear under a light. So if a light is able to make the colors visible true to its colors, then the CRI value is 100%. If the light is not able to make your eyes see the colors accurately, then the CRI value is less. So the trueness of colors that appear under that particular light is the CRI measurement. You can see in the two images here, when the CRI value is 90, you can observe that you can see the colors in a more accurate way, and when CRI value is 60, there is some accuracy that is being lost. The trueness of the colors is being lost. Understand? Next one is CCT, correlated color temperature. CCT means correlated color temperature. It is measured in degree Kelvin. This measurement indicates what tone of white light is emitted by the light fixture. You can see when the CCT value is 1900 Kelvin, that is usually by a candle, it emits a yellow light. The light color is yellow. So when the CCT, that is correlated color temperature, increases, you can see in the images the light is turning from yellow to white. Okay, natural white, and direct sun is giving the CCT value of 4800. If the CCT value, that is correlated color temperature value, further increases, the light will turn from white to slight bluish color. So you can see the blue sky is having a CCT value of 10,000 degree Kelvin. Understand? So what tone of white color is given by the particular luminary light fixture, it is given by the parameter called CCT. Lower values of CCT, it gives yellow light. In the middle range, it will get white light, and at a higher range, you will get slight blue tinge to the white light. The first type of lamps are incandescent lamps. So here the electric current is made to pass through a thin fine filament that produces visible light. The current raises the temperature of the filament. To such extent that it becomes luminous. The glass envelope, see here you can see it is an incandescent lamp. So it is the filament, you can see in the image, this is the filament, and this is a base, and these are the filament support wire, lead wire, glass bulb, everything you can see in the image. So what happens? So this filament is usually made up of tungsten. So the glass envelope, this inside this glass contains a mixture of nitrogen and a small amount of inert gas called argon. So what are the gases that are present in the incandescent lamp? Some inert gas called argon and small amount of nitrogen. Why inert gases are required? Inert gases do not react with any metal or any other things. So they minimize the evaporation of the filament because they do not react with the tungsten filament, thus reducing the blackening of lamp and increasing the filament life. Okay. Incandescent lamps have come a long way. Initially, Thomas Alva Edison made the first carbon filament lamp, which he introduced in 1879. So firstly the filament was made with carbon, and then later on they tried other materials, and then eventually they settled down at tungsten, which is having the ideal features for this application. Okay, so today commonly available incandescent lamps have average life of 750 to 2000 hours. The most widely used filament material is tungsten because of this high luminous efficacy. What is luminous efficacy? The number of lumens given per 1 watt of electrical power, that is luminous efficacy. Okay, so it can give 18 lumens per watt when it is operating at 200 degrees centigrade, and it can give a luminous efficacy of 30 lumen per watt when operating at 2500 degree centigrade. Understand? So what are the points that you have to remember? So here the glass envelope contains gases of nitrogen and small amount of inert gas like argon. That is one point. And inert gases are used so that they reduce the evaporation of the filament and thus increases its life. And the most widely used the filament material is tungsten, and it has a luminous efficacy of 18 watt at 2000 degrees centigrade and an efficacy of 30 lumens per watt when it is operating at 2500 degree centigrade. Understand? The luminous efficacy of incandescent lamp is directly proportional to the square of voltage. The luminous efficacy is directly proportional to the square of voltage. Understand? So this is the image and different parts of the incandescent lamp. You can pause and verify them. Incandescent lamps are strongly affected by the input voltage fluctuations. By reducing the voltage by 10%, definitely the luminous output also reduces by, I said no, lumens emitted by the lamp is directly proportional to the square of voltage. So if you reduce by 10%, the lumens or the illumination reduces by 20% approximately. So, but what is the advantage? The longevity of the life of the lamp is extended. But if you increase the voltage by 10%, definitely it will increase the illumination by 20%. Brightness of the lamp increases by 20%. But however, its life will be reduced to half. So it is very highly sensitive to the voltage fluctuations. So what type of the properties are required for the metal that is used for the filament? it should have high melting point, high specific resistance, low temperature coefficient, low vapor pressure, and highly ductile. Okay, so what are the ideal features? High melting point, high specific resistance, low temperature coefficient, low vapor pressure, and highly ductile. The reasons are mentioned here. Okay, so material used in the filament are carbon, osmium, tantalum, and tungsten. So eventually they all settle down at tungsten filament. Okay, gas inside the used is nitrogen or argon. Inert gases. Life is roughly 1000 hours. Lamp efficacy is between 10 to 30 lumens per watt. An incandescent lamp generates light through heat. 90% of the energy is wasted. 90 to 95% of input energy is wasted in the form of heat. Only 5 to 10% is being converted into light. Okay. So advantages of the incandescent lamps. They are ideally suited for small area lighting. They have excellent color rendering index, which is 100%, which is the highest or the best possible value. They are very cheap to produce. No toxic materials are disposed like mercury and toxic alloys. That means they can be easily disposed and they can be used in the strobe and dimming circuits. Disadvantages. They are not energy efficient. Why? Because 90% of the energy is wasted in the form of heat. Only 5 to 10% is being used for the light. Incandescent lamps are not used for lighting large areas. It takes many to light a large area because we require more number of lamps to illuminate. So there are better options for illuminating a large area like high intensity discharge lamp like metal halides or LED lamps are usually used these days. Understand? Tungsten halogen lamp. Halogen lamps are like this, you can see from the images. Unlike incandescent lamps, use of halogen gas fill. So that means the lamps are surrounded or enveloped by halogen gas, typically iodine or bromine, to produce what is called halogen cycle. In halogen cycle, halogen gas combines with the tungsten filament or tungsten that evaporates from the lamp filament, and eventually it redeposits the tungsten on the filament instead of allowing it to accumulate on the bulb wall as it does in the incandescent lamp. So what happens when you pass the current through the tungsten? Some portion of tungsten gets vaporized and it deposits on the surface of the lamp so that a blackish tinge is formed. But whereas in this halogen lamp, this evaporated tungsten combines with the halogen, and because of this halogen cycle, again it gets redeposited. Vaporized tungsten, again it gets redeposited on the tungsten filament only, so that it increases the lifetime of the tungsten halogen lamps. Okay, so the tungsten halogen lamps have several differences from incandescent lamps. They have longer life. The bulb valve remain cleaner because of the evaporated tungsten is constantly redeposited on the filament by halogen cycle. The lamp walls remain cleaner because of this halogen cycle. So the luminous efficacy or the efficiency will remain same throughout the life because the surface wall is cleaner. The bulbs are more compact and they have better optical control. Halogen lamps sometimes are called quartz lamps because of the higher temperature. Instead of using normal glass, we use quartz as a envelope. So in incandescent lamps, we use normal glass. In halogen lamps, sometimes we use the quartz envelopes. Okay. So wattage is 20 to 50 watt. We can get a 12 voltage. We can get up to 1000 watt lamps at 230 voltage. Luminous efficiency is 23 to luminous efficacy is 23 to 25 lumen per watt. Okay. So what are the advantages? They are more compact, longer life, they give more white light. Disadvantages: costly, increased IR and UV radiations, handling problems. Okay. So what is the important point here? You have to remember what is halogen cycle. In halogen cycle, the tungsten is redeposited on the filament, which will elongate the life and makes the lamp cleaner. Next, fluorescent lamps. The most common commercial lighting technology nowadays, the fluorescent lamps are being replaced by the LED lamps. High efficiency or efficacy, which is 100 lumen per watt. A fluorescent lamp tube is filled with a gas containing low pressure mercury vapor and argon, xenon, neon or krypton. So the tube rod is filled with definitely with mercury combined with some inert gas. The inert gas can be any one of these, not all. Either it can be argon, xenon, neon or krypton. So it is a combination of mercury plus some inert gas. Understand? And the pressure of the mercury is very low. The pressure inside the lamp is around 0.3 atmospheric pressure. The inner surface of the lamp is coated with fluorescent or phosphorus. It is coated with phosphorus. What is the property of this fluorescent or phosphorescent is that usually when the gaseous mixture inside the lamp, once it discharges, it will emit the ultraviolet radiations. This phosphorus coating on the surface of the lamp converts this ultraviolet light into white light, which can be sensed by our eyes. That is the purpose of this fluorescent coating or phosphorus coating, which is on the surface of the tubelet walls. The lamp electrodes are typically made up of coiled tungsten. So electrodes are made up of coiled tungsten and referred as cathodes because of their prime function of emitting electrons. For this, they are coated with a mixture of barium, strontium and calcium oxides chosen to have low thermionic emission temperature. Understand? So how does it work? So in the beginning, when you give phase and neutral, this is phase and this is neutral, through the ballast or choke, what happens? The supply will go to this fluorescent lamp, the phase is here, and through this one, again it will go to something called as a starter. This is the starter of the tube light, and the neutral, it will go through this path, and neutral is provided here. So initially what happens? There is a bimetallic strip inside the starter. So the starter gets heated and it gets short circuited. So once the starter gets short circuited, then a high voltage is developed across the filaments of the tube light. So this high voltages causes the discharge, breakdown of the gas. The mercury vaporizes and breaks down, and then the gas starts conducting. Gas discharge happen and gas starts conducting, and the lamp will give the illumination. So once after starting, you can remove the starter, still the lamp will glow. Cathode filament emitting electrons after getting heated due to supply of current. These electrons, while accelerating, collide with argon and mercury vapor atoms. The excited atoms of mercury gives a radiation. So once a high voltage is applied across these two filaments, the mercury evaporates and it gives a radiation. Understand? Advantages of fluorescent tube is that voltage fluctuation has very small effect on the light output. The luminous efficiency is more, and as the rod length increases, it further increases. It gives light close to natural light. The heat radiations are negligible. These are the 4 advantages. Advantages are voltage fluctuations does not affect this fluorescent lamp much. It has very good luminous efficiency or luminous efficacy. It gives light closer to natural light, and it does not produce much heat. Disadvantages: its brightness is less, cost is more. Incandescent lamp will cost you 10 rupees, but this total setup will cost you 200 to 300 rupees, and even it requires some maintenance. Compact fluorescent lamps, CFL. So fluorescent lamp that is smaller in size, that is 2 inches in diameter or 3 to 5 inches in length, developed as a replacement for incandescent lamps. There are 2 main types of CFLs: ballast integrated, ballast not integrated. Ballast not integrated. Understand? So they use only 1/4 of the power of the incandescent lamp. 18 watt CFL is equivalent to 75 watt incandescent lamp, and the life hours is 10,000, approximately 10 times that of incandescent lamp, and they will give a lot of cost saving. So CFLs are ideal replacement for incandescent lamps. They have 10 times more life, and they give better luminous efficiency, and they give a lot of cost saving. Understand? So these CFL lamps you have seen in your household. So what is ballast and role of the choke? Ballast performs mainly 3 functions. It provides high starting voltage. Why high starting voltage is required? Because to discharge, to create the discharge or through the gas which is having high resistance. Provides operating voltage under normal working conditions. Limits the starting current. Because whenever there is a short circuit across the starter, the current will be very high, but however this choke will limit the current to a safer value. Previously we used to have electromagnetic ballasts. Nowadays electronic ballasts have come, which are lighter, less noisy, and which operates better. Okay, new ballasts are electronic, old type of ballasts were electromagnetic. You can see in the image, it is electromagnetic ballast, and this is electronic ballast. Okay, so now the second type of lamps are high intensity discharge lamps. So there are 3 types of high intensity discharge lamps, 3 or 4 types, but most of the operating principles or the equipment are common. They have one glass envelope. This is called Pyrex envelope, which resists the thermal shock, that is heat shocks it will absorb. And special gases that are enveloped inside this gas or filled inside this gas, firstly definitely it will have some mercury and some form of inert gas. Why inert gases? Inert gases do not react with other things, and they produces less residues. And depending upon the type of the high intensity discharge lamp, you may have sodium. In case of sodium vapor lamps, you may have some sort of halides in case of metal halide lamps, and only mercury and some inert gas in case of a mercury vapor lamp. And there will say quartz arc tube. This is in this arc tube only the discharge occurs initially, and it will produce the light. So this quartz arc tube, why it is made up of quartz? So that it can withstand very high temperature without getting broken or damaged. Helical electrodes. It has one starting electrodes, and bimetallic switches are there, and a nickel base. Nickel plated steel supports. These are the steel supports which resist the shock and the vibration, and these are the electrodes. This is one electrode, and this is one more electrode. Understand? This is the general structure of high intensity discharge lamp. They can be oval shaped or rod shaped, as you can see in the images. So high intensity discharge lamp produce light by means of an electric arc between tungsten electrodes. All that these two electrodes are made up of tungsten only. These two electrodes are made up of tungsten. Okay. So HID lamps produces light by means of an electrical arc between tungsten electrodes housed inside a translucent or transparent fused quartz or fused alumina. Either you can use quartz or alumina arc tube filled with special gases. So this arc tube is filled with special gases and an arc is produced between the two tungsten electrodes through this arc tube, which contains some special gases. Then the light starts glowing. So the common circuit for all these HID lamps is that this is this one, this is phase, this is neutral. So the phase goes through the ballast, and from ballast, if igniter is present in the lamp, to the igniter, one connection of igniter will go to the lamp and other end it will go to the other end of the lamp, and the capacitor is connected between the phase and neutral to improve the power factor. So what is the function of igniter? Igniter to provide a strong and hot enough arc of light. Igniter ignites. It provides a strong and hot enough arc of light strike the lamp by overcoming the resistance of the gas in the lamp. So it is the one which produces the arc in the quartz tube between the electrodes. Function of capacitor is to improve power factor. Arc tube can be filled with various types of gases and metal salts. HID lamps are used in industrial highway applications, gyms, outdoor lighting, parking decks, street lights, stadiums, etc. Their luminous efficacy is around 150 lumens per watt. They have long life, around 25,000 hours. The drawback of them is they'll take some time to get to their complete illumination. Usually 5 to 15 minutes they will take to come up to the full light after power up. So once the power is gone, again to start them, it will take some time. There are 4 types of HID lamps. The first one is high pressure mercury vapor lamp. Nowadays they are becoming obsolete, outdated. Metal halide lamps. Arc tube contains argon, mercury and some metal halides. Whereas in case of mercury vapor lamp, they will only contain one inert gas and mercury. High pressure sodium lamps, low pressure sodium lamps and xenon lamps. So these are different types of HID, high intensity discharge lamps. High pressure mercury vapor, metal halide, low pressure sodium lamps, high pressure sodium vapor lamps and xenon lamps. So mercury vapor lamp, so the arc tube contains argon and mercury. Arc tube contains argon and mercury. The outer envelope contains nitrogen gas. The outer envelope contains the nitrogen gas. Understand? So here different parts are given and the 2 electrodes are there here. So when the supply is switched on, full voltage is applied across the main and starting electrode. The voltage breaks down the gap and discharge through argon gas takes place. Discharge through the argon gas in the quartz tube takes place. As the lamps warm up, mercury is vaporized. With increase in the vapor pressure, the discharge takes a shape of intense arc. After 5 minutes, the lamps give full light. It gives greenish blue color. The lamp is always suspended vertically, otherwise inner glass may break due to excessive heat. Understand? So firstly, when full voltage is applied across the 2 electrodes, the argon gas breaks down and then mercury gets vaporized as the gas gets heated up, and a light arc is produced between the two electrodes. The lamp starts with a small arc between the starting electrode and the main electrode. The arc goes through argon gas, which easily strikes even in cold weather. This little arc heats the tube, and over several minutes the tube gets hot enough to vaporize the solid mercury struck to the sides. The mercury vaporized creates a strong light between the two main electrodes. First the argon gas gets discharged, and then after a few minutes the arc heats up the tube, and tube gets hot enough to vaporize the solid mercury struck on the sides. The mercury vaporized creates a strong light between the two main electrodes. Okay. So on the mercury lamps, phosphorus coating will be there. Fluorescent coating will be there on the mercury lamps. Fluorescent or phosphorus coating would be there on the surface of the lamp. So even the HPMB lamps appears white in color. The mercury vapor lamp is a negative resistance device. This means its resistance decreases as the current through the tube increases. Therefore, it requires a ballast to limit the current through it. Definitely HPMB lamp requires a ballast. Long life, low initial cost, poor luminous efficiency. It only gives 30 to 65 lumens per watt. It is less when compared to other HID lamps. Pure luminous efficacy when compared to other HID lamps. CRI value is 3. Color temperature is intermediate. Lamp life is 16,000 to 24,000 hours. These are some features of this lamp. Advantages. So in 1980s they used to have good luminous efficacy, but in latter stages we got better options. Color rendering index is better than that of HPFC sodium lamps. Some lamps are lost their lifetime is more. Disadvantages: it contains traces of mercury. Mercury is a toxic substance, so we should properly dispose it. So we are having high pressure sodium lamps have better lumens per watt when compared to it. Human skin looks green under this light. It is poor for color film or photography. Warm up time is required to start the lamp. These are few disadvantages. Next is sodium vapor lamp. An electric discharge, again the same principle. There will be an arc tube filled with some gases. So while starting, 450 volt is applied across the lamp to start the discharge. After 10 to 15 minutes, the voltage across the two electrodes will fall to 150 volt because of low power factor. To improve the power factor, capacitor is connected across the supply. The color of the light that is produced is yellowish. So sodium lamps produce yellow light. Understand? Used in outdoor and industrial applications. It consists of ballast. Igniter. Igniter is required for sodium lamps, and ceramic arc tube. So what are the gases that are present in the arc tube? 3 gases: sodium, mercury, and inert gas is xenon. So it consists of a ballast is required, igniter is required. In the ceramic arc tube, you are having xenon, sodium, and mercury. No starting electrodes. High efficiency. Its luminous efficiency is 60 to 80 lumens per watt. CRA value is 1 to 2. Color temperature is warm. Lamp life is less than 24,000 hours. So its luminous efficacy is better than mercury vapor lamps, and life is less. Good luminous efficiency. Smaller size than the high pressure sodium fits into many fixture types. Can be retrofitted into old mercury vapor fixtures better bulb than low pressure sodium lamps. Disadvantages: very poor color rendering index, requires a ballast which causes some power loss. It reduces the efficiency of the lamp when you count the whole system together because ballast will consume some power. Low pressure sodium vapor lamps. So it is highest luminous efficiency out of all this. Poorest quality of light because light color appears black and white or gray shades. Limited to outdoor applications. Color rendering index is 3. Color temperature is yellow. So everything appears yellow. Everything appears yellow in the low pressure sodium vapor lamp. So your faces, your skin, table, everything will appear yellow. So they are mainly used for those applications where the color rendering index is not matter. For filming in you should have high CRI value for those applications where color reproduction should be accurate. Suppose if you are going in a movie, the colors on the screen should be accurate. Or if you're going to a shop to buy some clothes, then your eyes should be able to see the color of the clothes accurately. So depending upon the application, you have to choose the different types of lamps. Suppose you are illuminating a street. So in street, suppose if you are illuminating a large area where the color accuracy is not a much matter, then you will go for those lamps which gives high lumens per watt, but the CRI value can be CRI value or CCT value may not be very accurate values. Understand? So mainly they are used for street light and outdoor applications because the CRI value is less. Everything will appear yellow under these lights. And the advantage of this one is it is having highest luminous efficiency or luminous efficacy. Understand? It is very efficient lamp, powerful lamp for use in large areas. Despite a warm time up of 5 to 10 minutes, it restarts immediately if there is a burnout. Suppose suddenly because of power outage the lamp has stopped and you can immediately restart it. And lumens output does not drop with age, such as LED or incandescent. The luminous efficacy will not change with the aging of the lamp. Disadvantages: worst color rendering for any lamp. Sodium is hazardous material which can combine when exposed to air, as if it is bulb is broken and trashed. So we have to properly dispose these lamps. Metal halide lamps. So most common high intensity discharge lamps used today is metal halide. Metal halide. Better efficiency, better CRI, better lumen maintenance. Largest choice of color, size and rating. Better efficiency than other HID lamps. It is under 80 to 100 lumens per watt. Require high voltage ignition pulse, but some have third electrode for starting. Lamp life is between 6,000 to 20,000 hours. They are used for floodlighting in stadiums, indoor stadiums, gyms, etc. Landscape lighting, shopping malls, showrooms, supermarkets, etc. Okay, so the most commonly used HID is metal halide lamps. They are having good CRI, good luminous efficiency, and they are available in wide range of colors and ratings, and lifetime is also good, and these are commonly used applications. So again the same structure, assembly of quartz or ceramic tube, and the electrode is commonly called as this arc tube. We call it is made up of quartz or ceramic. We call it as an arc tube like in other lamps. It contains mercury. Definitely every lamp, every arc tube contains mercury and some metallic iodides, metallic iodide discharge. Arc tube contains what? One inert gas, argon or xenon, starting gas, mercury and metal halide salts. See, every high intensity discharge lamp will contain one inert gas for starting the arc, mercury for sustaining the arc, and sodium in case of sodium vapor lamps, and some metal halide salts in case of metal halide lamps. In case of HPMV, there are no other. One inert gas and one mercury only. Okay. So metal halide arc tubes operates at a temperature of 900 to 1100 degrees centigrade. Average life is given. Wattage, they are available in a wide range of wattage from 35 to 1500 watt. Luminous efficiency is between 65 to 110 lumen per watt. Advantages: more pure white light than populous high pressure sodium lamps, close to daylight frequency which allow use to be used for growing plants. So more pure white light than other popular high pressure lamps, close to daylight frequency, and even we can grow plants in this metal halides. More energy efficient than mercury vapor and halogen lamps, great lumens output, good for indoor and outdoor due to good light quality. Okay. Disadvantages: expensive, light pollution. The light is so bright that it can produce much more light pollution than high pressure sodium or low pressure sodium street lamps. The whites from the metal halide lamps are closer to daylight in frequency. Understand? So metal halide produces which type of light? White light. Understand? So these are some advantages and disadvantages. Next is neon lamps. So they are mainly used for signboards. They are also, it is also called as cold cathode discharge lamps. The other name for it is cold cathode discharge lamps. These lamps are operated at very low temperature, 200 degrees centigrade. That's why they are called cold cathode discharge lamps. The electrodes are housed at the two ends of the tube. Tube contains neon gas. Neon gas discharge gives characteristic red light. Neon discharge gives characteristic red light. Understand? So the neon lamps contain neon gas along with. Neon lamps are generally used for advertising. Most of the letters having two ends at which the electrodes are placed. In a letter having more than two ends, the tube path is repeated for some portion. Advantages: good lumen per watt performance. Neon performs more reliably in cold weather conditions than hot cathode fluorescent lamps. More reliable than LEDs for airport runways landing. 50 lumen per watt when given in red color. 65 lumens per watt in green color. Disadvantages: shape of the tube is a limitation. Argon is not reliable in cold temperatures. Diffused light, not good for any focused beam applications. So it contains a combination of neon plus argon. They are mainly used for light advertising, and two electrodes are kept at the two ends. Electrodes are kept at the two ends of the letter. The next type of lights are induction lights. So induction lights are generated based on the induction principle, just like our transformer. Light source in which the power is required to generate light is transferred from outside of lamp envelope by means of electromagnetic induction. Light source in which the power is required to generate light is transferred from outside the lamp envelope by means of electromagnetic fields. So the tube which has to be glown, the energy is supplied through induction. It is a type of fluorescent lamp, uses radio waves rather than arc to excite a phosphorus coating on the lamp to glow. Long lifespan due to lack of electrodes. Its lifespan is very high, 65,000 to 1 lakh hours depending upon the lamp model. High energy conversion efficiency, luminous efficacy 60 to 90 watt. High power factor due to low loss of the high frequency electronic ballasts, which are typically 95 to 98% efficient. Minimal lumen depreciation compared to other type of lamps, as the filament evaporation depletion is absent. The energy is transferred through induction, so all these conventional disadvantages are not there. Instant on and restrike. it doesn't take any time lag for initial switching as well as switching after some disturbance. Instant on and hot restrike. Environmental friendly as they use less energy and less mercury per hour of illumination. Understand? So this is an induction lamp. You can see this is a tube light. This is a lamp structure and energy is transferred through induction. And this lamp is having a phosphorus coating, that's why it is appearing white. So phosphorus coated glass tube or envelope. So this energy is supplied through electromagnetic induction. So for this we are supplying the phasor neutral to this electromagnetic coil, and this coil through induction it is providing energy to the phosphorus coated glass tube or envelope, which again is creating the arc and it is getting the illumination. Understand? Induction lamps create light by using electromagnetic field to excite the mercury particles mixed in the inert gas like argon or krypton. The mercury creates a UV light, and as I said, mercury creates an ultraviolet light, and a phosphorus on the inside the walls of the bulb or tube filters the energy into visible light. This is what happens even in the fluorescent lamp. Okay, so induction lamps works on which principle? Induction principle, and light is created by electromagnetic field which excites the mercury particles which are in the combination of some inert gas like argon or krypton. This mercury creates an ultraviolet light, and a phosphorus on the surface of the walls filters this energy into visible light. Again, it's a type of a fluorescent light. Unlike a standard fluorescent light, it does not have an electrodes. The lamp has three parts: frequency generator or ballast, discharge tube and electromagnetic. A discharge tube, a ballast and a electromagnet. First, the ballast creates high frequency currents. The current is sent through the electromagnet and an electric field is produced. Energy is transferred from magnet to the mercury in the tube in the same way as the transformer works, that is induction. Understand? This point is important. Energy is transferred from electromagnet to the mercury tube in the same way as that of the transformer. How the transformer works, that is through induction. The mercury vapor emits ultraviolet light which strikes the phosphorus and makes it a visible light. Read out these advantages and disadvantages. Okay, so one of the main disadvantages is that this is not widely used technology because of the cost and because the ballasts have high failure rate. This technology is not under commercialized. It is not widely commercialized, so that you cannot find these induction lamps in wide variety of applications. The major problem is high failure rate of chokes and electromagnetic interference because of the presence of the electromagnetic. Understand? The most popular types of luminaries, fastly growing lights are LED lights. Invented in 1962, LEDs are semiconductor devices that produces light. LEDs are semiconductor devices that produces light when an electric current is applied to them. Understand? They directly convert the electrical energy into light. In the past, they used to use as indicator lights, automotive lights and traffic lights. Now they are used for maximum indoor and outdoor applications. They work on the principle of electroluminescence. So electrons recombine with the holes in a semiconductor PN junction to release the photons. So if you understand the PN junction philosophy in any semiconductor material, so these electrons will combine with a electron deficient portion called a hole, and when these electrons recombine with the holes, they release their energy in the form of photons. Understand? So they are highly energy efficient, low energy consumption, smaller in size, very fast switching, greater durability and reliability, very good luminous efficiency, 130 lumens per watt, RGB method mixing of proper amount of light from red, blue and green, they give white light. Understand? RGB method of mixing of proper amount of light from red, green and blue, LED yield white light. LEDs yield white light. So LEDs create light by electroluminescence in a semiconductor material. Electroluminescence is a phenomenon of a material emitting light when electric current is passed through it. So electroluminescence is a phenomenon of a semiconductor material which emits light when electric current is passed through it. Understand? It is a property of a semiconductor material to emit light when electric current is passed through it. It happens when electrons are sent through a material and they fill the electron holes. An electron hole exists when an atom lacks electrons and therefore has a positive charge. Semiconductor materials like germanium and silicon can be doped to create and control the number of electron holes. So you might have studied doping is adding some other materials to create either more number of free electrons or more number of holes. Understand? So by doping, what is happening? We are creating more number of holes, and when electric current is passed through them, these electrons from the source, from the external supply, they go and combine with these holes that are created by the doping, and as a result they emit light, energy in the form of light, in the form of photons. That's why the LEDs will glow. Understand? So that is what they have explaining. So as the electrons pass through one crystal to the other, they fill the electron holes, they emit light in the form of photons. Understand? They emit energy in the form of light. That is the electroluminescence. So LED applications, you can see in the image, when the fluorescent tubes are replaced with LED, how different is the illumination. Successfully today in many markets, signs and traffic signals, displays, exit signs, indicators, flashlights, parking garage, outdoor food freezers, everywhere they are being replacing the conventional lights. Highly energy and efficient. A typical LED requires 30 to 60 milliwatt-hour to operate. Durable and shockproof unlike glass bulb types. Directional nature is useful for some applications by reducing stray light pollutions. They give direct focused light, so they are useful for some applications where stray light pollution is not required. Disadvantages may be unreliable for outdoor applications with great variations in summer and winter temperatures, because the semiconductor materials are they are sensitive to temperature variations. Semiconductor are sensitive to be being damaged by heat, so large heat sink must be employed to keep the powerful arrays cool. Sometimes a fan is required. So heat sinking should be properly done, otherwise the semiconductor material may get damaged. So rare earth metals are used in LEDs subjected to price control. Because of we are using the semiconductor materials which are very rare. So because of the shortage of the semiconductor material, the price fluctuation may happen. Currently we are seeing there is a shortage of the semiconductor chips. That's why all your appliances like cars and other appliances where you require semiconductor electron chips, they are getting delayed or they are becoming more costly. Understand? So over the time, the lumens emitted by the lamp will reduce. These are the disadvantages of the LED lamps. So again, in one more image you can see. So this is illuminated. The first image is illuminated with 36 watt LED, and the second image is illuminated with 160 to 230 watt metal halide. You can see they are almost comparable. Illumination is comparable. So they are highly energy efficient. So comparing the lamps, incandescent lamps, average, you can see average lumens per watt. Lumens per watt is efficiency, luminous efficiency or efficacy. So it is 14. For fluorescent lamps it is 50. For CFL it is 60. HPMB 50. Halogen lamps 20. High pressure sodium vapor 90. Low pressure sodium vapor 150. Understand? So color rendering index is excellent for incandescent and very pure for low pressure sodium vapor. Understand? These are the typical applications where you can use the incandescent lamps, fluorescent lamps, CFL lamps, everything. And live hours are given here. So you can go through this slide carefully. Understand? So hazardous waste disposal. So it's very important that the many lamps that we have discussed, usually high intensity discharge lamps, contains mercury. Even CFL contains mercury. So mercury is a toxic material and we should limit its quantity. Understand? So nowadays, disposing this mercury tube lights, they are asking us to replace all this mercury HPMB lamps with LEDs. Why? Because we have to reduce the toxic wastes that are being emitted from this one, and they should be properly disposed. So mercury containing lamps like fluorescent HID is treated as an hazardous waste under the current federal law. So the rule applies only to the lamps that fail TCLP, toxic characteristic leaching procedure test, when it is used to determine if the waste is hazardous or not. Understand? So different mercury content of different lamps is given here. You can see that the T12 fluorescent lamps contain 45 mg of mercury. Metal halide contains 38 mg. Actually, mercury vapor contains high. That's why they are becoming outdated or obsolete. So nowadays they are not recommending us to use the HPMB lamps. Understand? So nowadays all conventional lamps are being replaced with LED. LED lamps, because LED lamps do not have any toxic discharges, toxic waste. They don't have any hazardous material. So ideal choice is LED nowadays. Understand? So thank you very much.